Hello, guys. So let's actually look at this exciting topic, right? So we want to look at chemical equilibrium, right? So like this is the topic that we want to start, chemical equilibrium. So I'm gonna define what chemical equilibrium is, as we actually proceed with this topic. But for now, I just want us to look at the Kc value, right? So what is the Kc value and how do you calculate it and what's actually happening? So Kc actually stands for, okay, let me not actually speak about it for now. I'm pretty sure you've already done it in your class, but like how do you calculate the Kc value? So I just want to just go to how to calculate the Kc value and then just deal with that. So now, suppose you have got 3AB, right? So let's say you have got 3AB plus 2 2CD, and they give you a reversible reaction. So a reversible reaction is given by a forward arrow and a back arrow, right? So this forward arrow refers to the what? To the forward reaction. This is the forward reaction, and then this back arrow right here represent the reverse reaction, right? Reverse reaction. So I'm going to give you an example of a forward and a reverse reaction, right? So let's say that if we have got 3AB plus 2CD, and let's actually say that in products, this actually give us, I don't know, I'm just going to make up any number. Let's say this actually give us 8ABCD, right? So we actually have got 3AB plus 2CD, that actually give us 8ABCD. I'm just gonna writing any numbers, right? Because I want to show you something. Now, what is an example of a reversible reaction? So an example of a reversible reaction, let's look at, let's just look at liquid water, right? Let's just look at liquid water. So let's say this is actually liquid water. So let's say this is our liquid water. So this water is just right here. It's actually liquid water. So if we decrease the temperature, what's going to happen? We realize that the water is actually going to freeze, right? So we're going to move from liquid water to solid water, right? To solid water. And this solid water, we're going to call it an ice, right? So this one, we're just going to call it just normal water, drinkable water, if I might say. And then this one is just going to be an ice. So this is what happens if we decrease the temperature. So if you have got normal water temperature, so if you have got the normal water, this is just water, right? Is you have got the normal water and then you decrease the temperature, what's actually going to happen? You know that this normal water is going to change into solid water. And what is the name of the solid water? We call it an ice. So now at this point, we just have a block of an ice, right? So now let's say that we call this one a forward reaction, right? Let's just call this one, let's just name it. We're just going to call it the forward reaction, right? So now what is the reverse reaction? So the reverse reaction means that the reverse reaction actually means that what do? It means that we decrease the temperature, we increase the temperature. So initially we decrease the temperature. So if we want to have a reverse reaction, we just now need to to increase the temperature, right? We increase the temperature. So if we increase the temperature, remember, we now have a solid, which is an ice, right? So if we decrease the temperature, what are we going to have? We are just going to go back to to liquid water, isn't it? So it is a reversible reaction. A reversible reaction means that this reaction can goes, either way. It means that you can reverse it. It's a reaction which can be reversed. So if you change liquid water into solid water, that can be reversed, right? You can always you can always boil up water to just take it back to liquid water if it is an ice, right? You can just increase the temperature and the ice will just start to melt. So that is a reversible reaction. We can we can undo the reaction, right? We can undo the reaction. So it is called a reversible reaction. So if a reaction is not reversible, it is a reaction which we cannot undo it. So once we have got the product, we cannot go back to the reactants. So that is what that is actually implying. So by the way, what is an example of a non-reversible reaction? So like what could be an example of a non-reversible reaction? That is where we speak about, I don't know, death. I mean, like, if you're gone, you're gone, right? I don't know. I would just like say if you're alive, it's your reactants. I don't know. And then something happens, you get run over by a car, and then you're gone. Can't bring you back. But it is not like technically a reaction, but it's a situation where we can't like go back, you know. But what could be an example of like a non-reversible reaction in real life? I don't know. I can't think of anything. But like, just think about it, right? What about if we change liquid water into gas? But I think that is reversible, right? Because like, I think that's reversible. Let's say that you have your pot right here, right? Let's say this is your pot, and this is actually like water inside, right? So you are having like your fire right here. If you have your fire, what's gonna happen? You realize that the water is actually going to evaporate, right? So if the water starts to evaporate, if you put something here, right, you realize that that water is just gonna, you know, be stuck here, and it would be liquid water. So if you know how to cook, you know that when you close your lid, right, on a pot, when you open your lid, you would find like some liquid water on your lid, right? That shows that water was evaporating. So water actually moved from liquid to gas and then to liquid again when it actually hit the lid. So I think that's a reversible reaction. I don't know. I don't have any example of non-reversible reaction. I can't remember anything. But okay, let's actually come back to how do we calculate the Kc value, right? So like, what does this has to do with Kc value model? So I want us to look at something, right? Do you know this bracket, right? You know this bracket. These brackets actually have a meaning, right? So if you are dealing with Kc, we are going to look at the brackets like this. So this bracket has a meaning. It has a word. It means something, right? And what does that mean? I want someone to guess. You did not guess, buddy. Like, what does this bracket actually implies? You can even go and check ChatGPT. I don't know. Just like pause the video and just go and check ChatGPT. You can screenshot and say, hey, Chat, what does this kind of bracket imply on chemical equilibrium? Anyone with a guess? I know there's someone in Limpopo right now who's like probably sleeping at this point. Like, dude, what are you doing? I'm just kidding. So this bracket actually implies that this is concentration, right? So whenever you see that bracket means concentration. So if you find a bracket like this on chemical equilibrium, I think even on rates of reaction as well, that actually means concentration. So let's say that you are being told that this is A, right? So this means what? Concentration. This actually means concentration of A. Let's say that I draw you right here, you know, you kind of look like you know. There's a little person. It looks like you, right? I think I could change careers and just decide to pursue artistry, because there's no way you're going to tell me this little dude right here doesn't look like you. There's no chance in hell, right? So because that is you, even if you can get angry about it, I don't really care. That is you. You can see this person looks like you. So this means that this is the concentration, right? This is the concentration of you. Does it make sense? So this bracket actually implies concentration. So like, how do you write the Kc formula, right? So the Kc formula, so what is the Kc formula? So the Kc formula says that Kc equals to the concentration of the products, right? Products to the power of what? Of coefficient divided by concentration of reactants to the power of coefficient of those reactants, right? So what does this mean? How do we mean that the Kc is calculated by the concentration of the product raised to the coefficient of that product divided by the concentration of the reactants raised to the coefficient of that reactants. So let's actually just come back here, right? So which one is the products and which one is the reactants? So that is very important for you to identify on chemical equilibrium, especially if you are given a reversible reaction. Which one is your product and which one is your reactants? So let's say that we are dealing with the forward reaction. So which one is the forward reaction? By the way, we are having two reactions here. In this equation, we are having two reactions. We're having the forward reaction and we're also having the reverse reaction. So the forward reaction is given by, like, this is the forward reaction, right? It is given like by this arrow right here. The forward reaction is given that we start with this and this is our product. But the reverse reaction, as you can see, we are going this side. It means that we start with this and we end up with this. So let's actually focus on the forward reaction, right? So let's say that we are looking on the Kc for the forward reaction. So how do we actually calculate the Kc of the forward reaction? So like if you are dealing with Kc and you want to deal with the Kc of the forward reaction, you just like go back to your, I don't know, like to your formula and identify which one is the forward reaction. So what you want to do is you want to say, okay, this is the forward reaction. So now, what is my reactants on the forward reaction? So my reactants within the forward reaction, it is actually 3AB plus 2CD, right? So my reactants becomes 3AB plus 2CD, right? So the forward reaction means that we are starting with this side. As you can see that we are going on that other direction. So this actually becomes my reactants. So this is actually my reactants. So I'm just going to write this forward direction, right? So my forward reaction and my products becomes 8ABCD, right? So my product becomes 8ABCD. Right? So this is the equation for the forward reaction. And how do you calculate the value of Kc if you do that? You're just going to say, okay, Kc equals to, now, what is the concentration of the products? So you have to go back to your, to your equation and identify which one is your product. So here, this is our products, right? So we want to identify the concentration of the products. So just gonna say the concentration of A, B, C, D. That is our products. And what you want to do with that is you want to raise it to the power of the coefficient. Now the question is, what is the coefficient? Now, the coefficient are these little numbers that you find in front of certain variables, right? So like, let's say it is 2 magnesium chlorine, I don't know, chlorine, magnesiate. so like the coefficient is these two, right? So let's say we've got 3 carbon dioxide, magnesium. I have no idea what I'm saying, but like the coefficient here is going to be a 3, right? I guess you get the point of it. So when we say that, the way you calculate Kc, it is the what? Concentration of the products, and you raise it to the power of the coefficient. So you're just gonna raise it to the power of 8. Does it make sense? Because the coefficient at that freaking point is actually 8, right? So you're just gonna raise it to the power of 8 divided by, so when you go back to your reactants, so now I have to act a little bit smart right here, delete, and then I'm just gonna delete, right? So now, what is your reactants? So your reactants, you have got A, B, and you also have got CD. So you wanna write them as a separate. You don't wanna like mix them, right? You just have to keep them separate. It's like you and your ex, right? we want to keep you separated as much as possible, isn't it? I'm just kidding. Like, just imagine if you're like watching this video with your mother and she also has an ex. I'm just I'm just kidding. I'm just kidding. Okay, so let's just look at this, right? So we just want to look at the concentration of AB. So this is the concentration of AB. So this is the concentration of AB. And you want to raise it to the coefficient of that AB. And the question is, what is the coefficient of AB? It just becomes this 3. Do you see it? So you want to raise this to the power of 3, and you want to multiply this by the concentration of the other side, which is like CD, right? So you just want to multiply this with CD. And what are you going to raise this with? You're going to raise this one to the power of 2. So in your exam, you are going to be given the value of your concentrations, right? So you're going to be given the value of your concentration, and you're going to do it. So what I want you to do as your homework, yes, even you from Limpopo, even you from Giyani, even some of the people that stay in Malamulele Community Hall that are disturbing us when we are busy recording. Even you guys that are from, I don't know, Durban, I have no idea where you're coming from, dude. Like, you're really not that important. I'm sorry. I'm just kidding. I'm just kidding. But like, unless if you're from Malamulele, if you're from Malamulele, you could just get out, actually. I'm also from Malamulele, so like, don't catch. I'm just kidding. I'm not from Malamulele. I'm from Bush. I'm just kidding. I'm not from Bush. I'm from Pretoria. Is it Pretoria? No. I think I'm from Durban. Okay, I want us to do this, right? I want you to do this one as your homework. So what you want to do as your homework is focus on the reverse reaction, right? So calculate, I want you to find the Kc for the reverse reaction. So I'm just going to give you a clue. So our reactants is going to be 8ABCD, and our product is just going to be this. And I want you to find the Kc formula for the reverse reaction. I'm out, guys.